If all electric devices were powered by starter battery while the propulsion engine was off, there would be a risk that the battery would be so discharged that it would not be able to deliver enough electrical power to the starter to start the engine. The comfort of using other devices in this case would be significantly reduced because the user should always monitor the discharge of the battery. Therefore, on ships with DC systems, a second battery or several batteries are installed to power all other devices. And the starting battery retains only its basic purpose, which is powering the engine starter. When engine is turned on, generator supplies all electric consumers and charging both batteries. When engine is turned off and generator doesn't produce electric energy, additional battery supplies various electric consumers. In that case, diode doesn't allow current to flow from starter battery to other electric consumers, and starter battery is not supplying other consumers with electric energy and therefore it is not discharging. The diodes in the circuits of starter battery and additional battery have the role of enabling the charging of both batteries by electric energy from generator at the same time. On the other hand, in the process of discharging, diodes completely separate the circuits of these two batteries. So the starter battery cannot supply other consumers except starter. Either additional battery cannot supply the starter. Without diodes, the starter battery would be discharged along with the additional battery and could not provide enough power to starter. A much bigger problem than discharged starter battery would be the danger of destroying the starter due to overvoltage if additional battery would supply starter along with starter battery. The electric starter is installed in the system with a battery of a predefined capacity and is dimensioned so that a certain voltage drop on the battery inner resistance is already taken into account in starter construction. If this battery is replaced with one of higher capacity, or if other batteries are connected to it in parallel, the voltage drop across the batteries will be too small and the starter will be endangered by excessive voltage. For example, starter is constructed to work at 8 volts because voltage drop on the battery inner resistance is already taken into account. When additional battery is connected in parallel with starting battery, voltage drop would be too small, and starter would work at much higher voltage, for example 11 volts, and be endangered.